Hello guys, welcome again to this mathematical tutorial. And in this short lesson of arithmetic progression and arithmetic series, I'll be your course or lesson instructor. And if you are new attending this class, you are permitted to call me Regan Ayecho, or you can also call me, if you like, Prof. Regan Ayecho, as that's my popular name. So today we are going to talk about arithmetic series, and I want to hear in the comment section before we proceed, what do you understand by the term arithmetic progression? And if you know of a learner who deserves such a tutoring, don't hesitate to share to them, because it will be a helpful thing to them. Since we work, as you can see, I'm a young man, and the person watching, the person who are watching, is probably that you are a young man, as usual, I'm talking probability. So just don't hesitate to share so that we learn as young people. Without wasting of time, let me kick off the journey. Let's discuss arithmetic series. See you until the end. So welcome to today's class. This is understanding arithmetic. As you can see, the next lesson after it is geometric series. Today we are going to analyze deeply what arithmetic series is. We are going to do several examples, and also you are going to have your exercise as a student. And the next lesson, I can't also wait to see you, because we are going to study deeply geometric series. So let's first start by understanding what arithmetic is, and we're going to differentiate them. And as I told you, I'm Prof. Regan Ayecho. So let us start by understanding what arithmetic series is. What is a series, in fact? So a series, as you can see in my blackboard, is a sum of terms in a sequence. We have sequence and we have series. And most learners, if I not mistake, confused between these two things. Confused between series and confused as well between what is called sequence. So a sequence is a listing of numbers. You list like 2, 4 with a comma or with a full stop, but mostly it's a comma. In a sequence, they are listed. But a sequence becomes series when they are added. As you can see in my arrow pointing there, 2 plus 4 plus 8 plus 6, all those, that is now a series because all the sequences added. A sequence is listing, but the series is now the summation of the whole sequence. As I told you, no sequence as listing terms, and the series as what? As adding the terms. As we proceed, there are several examples there. As you can see, the listing of 2, 4, the listing of up to 10, and in the series we have 2 plus 4 plus 6 plus 8 plus 10, and it's equal to 30. And let's move on to the next part of our theme. There's what is called sigma notation or sigma notation, as you like to pronounce it. And sigma notation is represented by this symbol. So when I talk of sigma notation, you should be seeing this symbol, whereby in this end, here is whereby we are going to have the total number of terms written. Here is where the total number of terms are written. Here is where the total number of terms shall be written. And here we are going to have our second term. I'm going to explain this as we continue. And here we are going to put our formula. So this is called sigma notation. Sigma notation let us write series compactly instead of listing every term. Instead of doing this 2 plus or up to 10, we can use sigma notation as this symbol tells us. And examples is you can from k is equal to 1, and that one is the first term to 5 of 2k, means adding 2 terms, 2 into 1 plus 2 into 2 plus 2 into 3 plus 2 into 4 plus 2 into 5, which is equivalent to 2 plus 4 plus 8 plus say 6 plus 10 and all those. I don't know whether we are together, but let me hear in the comment section if we are still together so that we can do the elaboration more and more. So this is what is called sigma notation. You just use that symbol to represent what you are adding instead of listing all, because you have some of the terminologies or terms which are very, very large, and you can't add by one by one. You have to use what is called sigma notation. Say you want to add from the first term to the fifth term. You use sigma notation. So the key parts here, the k is the index variable, whereby the k is the index variable. It is actually varies because we have k is equal to 1, k is equal to 2, up to k is equal to nth term. That is the last term. In this case, our upper limit of the last term was 5, and that's k is equal to 5. Yeah, and you can see here, as you can see here, 2 into 5 as well. Let's proceed and see that sigma notation and see how we can use sigma notation. So arithmetic series introduction, and in this we are going to work with sigma notation so that you are able to understand it better. So let us define what a arithmetic series is. So this is a sum of terms where each term differs from the previous by a constant value, and this value is always called common difference, and it is denoted by letter D. So this is a series, is a sum of terms where each term differs from the previous term by a constant value called common difference. So the fixed amount added to each term to get the next term. Let us work with a real world example whereby I am saving $50 each month, and I've started in month 1 with my balance at 50. Month 2, I had 50, it becomes 100. Month 3, I had 50, it becomes what? It becomes 150. This is where my first term was 50, but I had 50, I had 50, I had 50 until the month I will decide now to stop saving. This 50 is what is called difference, common difference actually, and the 50 which I started with is called first term, always denoted by letter A. Let us go to the example series. Now tell me, in fact I want, before I work on this, tell me in the comment section what is the common difference in this series. I'm talking of this 52 plus 54 plus 56 plus 58 and so on and so forth. I want you to tell me what's the common difference and what's the first term, and maybe, yeah. So assuming you have got that correct, let us work it together. Here, the common difference denoted by D is equal to 2. Each term increases by 2 because from 52 to 54, you had 2. From 54 to 56 as well, you had 2. And from 56 to 58, you had what? You had 2. And the pattern cognition, the first term held A1 of ours is equal to what? Is equal to 52. The second term is equal to what? The second term is equal to 52 plus 2. And this is equal to 52. And the third term, the same, and so on and so more. The sum grows linearly as we add more term. Let us proceed and see what is prepared. So arithmetic series, we are going to look at the pattern. We are going to look at this pattern. So I want to give you a general form of how we work with this thing called arithmetic. Can you look at this thing? This is A1. This is the first term in our series. First term plus A1, first term plus D, common difference, that gives us second term. And the first term plus now 2D's, you multiply these times 2. That gives us third term, and so on and so far until we reach AN. AN is the nth term, and we're going to see how we can write the nth term. So first term being A and common difference being D, the nth term is equal to AN. AN is equal to nth term. Nth term is equal to A1, that is first term, plus n minus 1, and you bracket it into D because you multiply n minus 1 times D, all of them. So this is the formula of the arithmetic, nth term of arithmetic series. Can you tell me in the comment section if you're still with me so that we see what we can improve into this? Let's hear more from you. As we proceed, now in that we have seen very well the formula of getting what is called nth term of arithmetic series. I want us now to proceed and have what is called the summation, whereby we are going to look at now what we discussed earlier in this class, what is called sigma notation. So we're going to look at the summation of arithmetic series. What is the formula of getting the sum of arithmetic series? And remember, this is Prof. Ayecho channel discussing mathematical concept. Remember that if you don't follow, if you don't subscribe to my YouTube channel, this will miss you. And maybe you're struggling with this kind of mathematics. We don't do simple maths here, we do complex. And like this one was commented by a student in my last lesson, and I explained it. And I'm going to confirm whether he or she is satisfied with it. I'm waiting for your comment. In case there's any topic in any area you are struggling with, just leave me a comment there. And as well, you can get my contact in the bio, in my channel, or in my description in YouTube. I have put my contact there. Don't hesitate to reach out to get help. Why are you waiting? Leave a comment and let us see your help. So we are going to look at the summation formula. Now the sum. The sum of the first n terms of an arithmetic series is equal to n Sn. First sum of first n terms is equal to n into bracket a plus a1 plus an. This, what do I mean? N here is the number of terms. Like, say, I'm going to do an example actually. Say I have 50 terms. Here n is my n. 50 terms, number of terms is equal to n. Into first term, which is a1 plus last term, which is an, into bracket, divide everything by 2. And this is easy formula, which I prefer that you use it than any other. But because you are learners, you have to know everything here. Tell me if you have understood that first formula. But as well, I have for you an alternative formula, which is also very good. You put into bracket here n, that is number of terms, into 2a. The first term, you put it twice, 2a plus, into bracket, the way we were putting in the nth term, n minus 1 into d. Then you close the bracket and divide by 2, and you get your sum of first n terms of arithmetic. And both formulas give you what? Give you the same result. So we are going to confirm with you why this formula works. Why does this formula works? So I'm going to leave that one. If you know why, if you want to know the reason as to why the formula works, leave me in a comment section and I'm going to explain it in my next lesson. Either today, anytime I see the first comment, you are curious to know why the two formulas work, because I'm going to do what is called mathematical proof. give me a comment and I do it so that we keep the energy alive. Let me do an example before I leave you go. So find the sum of summation, that's our sigma notation, 2k plus 50. So we are starting from k is equal to 50 to from k is equal to 1, and that's the first term, to 550, and that is the last term. So identify the terms first. First term is equal to 2 into 1. Remember, the k is k, like, let me tell you, first term k is equal to 1, second term k is equal to 2, up to 550. Now it is multiplied by 2, and you proceed. But we are going to apply this formula, this one, instead of doing all this. So first term, 2 into 1 plus 50 is equal to how much? It's equal to 52, and that is our first term. Now second term is equal to 2 into what? 2 into 550, that's last term now. 550 plus 50, and that is what? It's 600. And how many terms do we have? It is 550 terms, because it's from K1 to 550. So the last term is equal to how much? The last term here is equal to 550 times 2. Don't forget, plus 50. And I think a mathematician should be able to know that, because it is around 1150. That is 1150. But let us confirm with a calculator. 550 times 2 plus 50, 1150. A mathematician should know some. Let us now stop guessing work and apply what? Apply formulas. Let us start by applying the formula of n into a1 plus an. I have told you what they mean, divided by 2. So, because we have the a1 and we have the a2, is 550 into 52 plus what? Plus 1150, as we got, divided by what? Divided by 2. And that is automatically 330,550. Then there is also verification there, because we can do the verification. D is equal to 2, and that's a common difference. Each term increases by 2, and the pattern confirmed answer. Let me show you a glimpse of what awaits you next. It's proving why the arithmetic works. I promise. Tell me in the comment section if you are ready for this proof, because I'm going to apply what's called mathematical proof. This is applicable for both secondary school students and university students, because for the engineer students, we must learn mathematical induction, and that's what I'm going to discuss in my first lesson, even if it's AI class. And by the way, even if it's AI class, I'm going to start by proving why arithmetic formula work. Just tell me in the comment section how you rate this class of today and what I can improve on. Let me show you where I will start. I'm going to start by introducing you to geometric introduction. Tell me how ready you are for us to be all ready. Oh, wonderful. Once again, hello. I hope you enjoyed the lesson we have just ended on Arithmetic Series. And if you enjoyed the lesson, please don't forget to leave me a comment, and don't forget to follow me, don't forget to subscribe to my channel, and also don't forget to share this with your peers who are interested in the same classes. One thing I want to urge you, that tomorrow I'm going to post an assignment in my timeline. It will be images. I just go there and download them and do. And if you are ready to submit, drop me the assignment into my WhatsApp number, and it is in my TikTok bio, and as well as it is in my YouTube channel. Don't forget to subscribe to the channel and follow. I'm yours, Prof. Tell me what you liked. See you again.